If you think baking is just about following a recipe, I'm here to tell you it's so much more than that. Your kitchen? It's actually a laboratory. And today we're going to uncover the amazing science that turns simple ingredients into something truly special.
Just look at that. It's fluffy, it's light, it's perfectly golden brown. How in the world does a soupy, messy batter become this? Well, it's not magic, I can tell you that. It's a whole series of brilliant chemical reactions, and we are going to break every single one down.
All right, to really get it, we've got to look at the pieces. So let's start with maybe the most dramatic part of the whole process, the rise. What is actually giving a cake that incredible lift?
Okay, it all comes down to this one word, leavening. You can think of leavening as the engine of your cake. The whole goal is super simple. Get gas into the batter. We're talking tiny bubbles of carbon dioxide that are going to expand and push that cake upward, creating that light, airy texture we all go crazy for.
Now, this brings us to that classic kitchen dilemma. Baking soda versus baking powder. What is the deal? Well, think of baking soda as the pure, raw ingredient. It needs a partner, an acid, like buttermilk or maybe some lemon juice to get the party started. Baking powder, on the other hand, is like a convenient little kit. It's got the baking soda and the acid already mixed in, which makes it a super reliable, all-in-one way to get a good rise.
So here's exactly what's happening. The second you mix your wet and your dry ingredients together, that acid and that base, they finally get to meet. And poof, they have a chemical reaction that releases carbon dioxide gas. And all those little bubbles get trapped inside the sticky, gooey batter, just waiting for the oven's heat to make them expand and bring that cake to life.
Okay, so we've got the bubbles. We've created the potential for lift. But let's be real, a bubbly liquid is not a cake. So the next big question is, how does heat turn that soupy batter into a stable, delicious sponge?
It seems like such an obvious question, right? But what is heat really doing inside that oven? Turns out it's not just one thing. It's actually 3 different forces all working together to build your cake from the outside in.
Your cake is getting cooked by like a 3-pronged attack. First, you've got conduction. That's the heat coming directly from the hot pan, cooking the batter it's touching. Then there's convection. That's the hot air swirling all around inside the oven, baking the top and sides. And finally, you've got radiation. These are invisible heat waves that actually penetrate into the cake to cook it more deeply. All 3 have to work together perfectly.
So if we were to zoom in way down to the microscopic level, this is what's going on. As that heat moves into the batter, it makes all these long, coiled-up proteins from the eggs and the flour, well, it makes them unwind and tangle all up with each other, kind of like a big knotted web.
And that tangled web of proteins, that is the absolute key. It creates a kind of scaffold. It's a solid, but still flexible structure that permanently traps all of those gas bubbles we made earlier. This is the moment the batter sets. It turns from a liquid into that solid, airy sponge.
All right, the cake is set, it's spongy, but what about that incredibly delicious golden brown crust? That amazing flavor and color? That is no accident. In fact, it's one of the most important chemical reactions in all of cooking. I want you to meet the Maillard reaction. Now, this isn't just browning. This is straight-up flavor creation. When the proteins and the sugars on the surface of your cake get hot enough, they start to react and create literally hundreds of new, complex, and delicious flavor and aroma compounds.
And here it is, the magic number. Right around 284 degrees Fahrenheit, that's about 140 Celsius, that's when the Maillard reaction really starts to kick into high gear. This is exactly why your oven temperature is so critical for getting that perfect crust.
Now, a lot of people mix this up with caramelization, but here's the simple difference. Caramelization is just sugar browning by itself. The Maillard reaction is way more complex. It's a beautiful dance between proteins and sugars. It's what creates those savory, toasty, roasted flavors you just can't get any other way.
And the power of this reaction, it's just incredible. I mean, to quote food chemists, this single reaction is responsible for creating thousands of different flavors and smells. We're talking everything from your morning coffee to a perfectly seared steak to the crust on this cake.
Okay, so we've got lift, we've got structure, and we've got flavor.
Now, for the really fun part. Let's see how knowing all this science gives you the power to troubleshoot, to experiment, and to tackle even the trickiest baking challenges out there.
Right. This is where knowing the why behind the recipe becomes your superpower. If you know that eggs are in a cake to provide protein for structure and also moisture, well, then how do you replace them? It's all about figuring out what job that ingredient was supposed to be doing in the first place.
So for instance, you can't just grab any old egg substitute and hope for the best. If you need binding and moisture for, say, a really dense brownie, banana puree is a fantastic choice. But if you need to create lift and structure for something airy like a meringue, you need something totally different. That's where you'd use something like aquafaba. It's just the liquid from a can of chickpeas, but it whips up just like egg whites. It's amazing.
And the exact same logic applies to gluten-free baking. Hey, remember that tangled protein network we were talking about a minute ago? Well, that's what gluten does in regular wheat flour. So if you take it out, you have to add something else back in, like xanthan gum, to build that essential structure so your cake doesn't just crumble into a pile of dust.
And what about those mug cakes you make in the microwave? Ever wonder why they can get kinda rubbery? Well, this chart shows that a microwave cake often has a way lower softness score. That's because the super intense, crazy fast heat from the microwave can make those proteins form a really rigid, tight structure instead of a soft, spongy one. It's a totally different way of cooking, and honestly, not always for the better.
So after all this science, what's the big takeaway? It's this. You've gone from being someone who just follows steps on a page to someone who actually understands the fundamental principles that make the whole thing work. You're a kitchen scientist now.
So here's your new toolkit. You now know how to master the lift, how to control the structure, and how to engineer the flavor. This is the foundation you need to experiment intelligently. Instead of just guessing, you can actually make educated changes to a recipe and have a pretty good idea of what's going to happen.
And that knowledge is incredibly empowering. When a cake doesn't turn out right, you can figure out why. When you want to try something new or go off script, you can do it with confidence. You can start to bake more intuitively, moving way beyond just the recipe page.
Because that's the real joy of science, right? Once you understand the rules of how everything works, you can start to bend them, maybe even break them, and create something totally new and delicious. Your kitchen is your lab now. So go on. Happy experimenting.